All right, just some common mistakes that I'm seeing on the Edulastics here. These are, this is the same base, 4 and 4. The exponents are different, 4 to the 7th and 4 to the negative 5th. So 4 to the 7th is 4 times 4 times 4 times 4, yada, 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 right? So we've got 7 fours here, and then you've got a 1/4 written 5 times, because negative 5 means that the exponent will take this and make it into a fraction. That base is going to be 1/4. So what happens is 1/4 times 4 is going to equal 4 over 4, and I'll show you why that is. 4, of course, is a whole number, can be written as 4 over 1. So 1/4 times 4 is 4 over 4, which is the same thing as 1. So what happens is this 4 and this 1/4, they equal 1. We'd like to say they cancel. These equal 1, this 4 and this 1/4. These equal 1. These equal 1. And then these will equal 1. So we're left with, these are all essentially 1. Every single one of these 10 numbers changes to 1. So you're left with 1 times 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 1. It all equals 1. Times 4 equals 4. Times 4 equals 16. So that's why it's 4 to the second power. You're really left with 2 4s there. Another mistake I'm seeing on this one right here, let me just get this thing out of the road. Oh boy, we can't even see it still. All right, it says 6 to the third over 6 to the sixth. All right, so you're going to be left with, if it's 6 to the third, there's 3 6s up there, and I'm going to draw these 6s kind of tiny on the bottom. So, whoops, those cancel, and those cancel. You're left with 3 6s on the bottom, and so, yeah, the only one that isn't equivalent is the one that says there's 2 6s on the bottom. This one, again, negative exponents mean that it's going to be a fraction, so that would be another way of writing this. And there it is right there, 3 6s on the bottom. And 6 times 6 times 6 is 216, so this would be okay. The one that doesn't make sense is up there. Number 11 here, you have to put these in order. So the square root of 64 is 8. The square root of 25 is 5. So I can see that this is 5, this is 8, this is 6. So it's just a matter of how big are these. Well, this says the cubed root of 27. In other words, what times what equals 27? And that would be 3 times 3 times 3. So the cube root of 27, this is actually 3. And the cube root of 64, well, it would have to be bigger than the cube root of 27 because this is a big number. It's going to be 4. 4 times 4 is 16, and then 16 times 4 is 64. So you can see all the numbers now. They're much easier to put in order. So it would be the cube root of 27. That comes first, right? That's the lowest number, 3. The second lowest number is 4. And the third lowest number is 5. And then finally, that would be 4th. And then this would be the biggest number of all. This one here, something times something equals 36. And it looks like the student wrote negative 6/11. That's not that far off. Here's 36. Here's 121. So it says x squared. So it's the same number times itself. Well, 6 times 6 will equal 36. And 11 times 11 will equal 121. So, technically speaking, negative 6/11 times negative 6/11 does equal 36 over 121. I think that they were looking for you to put the positive version of this, but I really think you could argue that this is actually a correct answer on number 15. Number 16 right here, it says 5 squared plus 5 squared. Order of operations. If you remember order of operations, you always want to do parentheses first, then exponents, and we actually added roots to this as well. So like, square roots and cube roots, things like that. Multiplication and division would come next, and it doesn't matter the order that those are in. And then subtraction and addition, or addition and subtraction. It really depends on what comes first in the problem. So as I look at this, exponents is the first thing you would do. So you get 25 plus 5 squared. And then you'd want to do exponents again. So it'd be 25 plus 25. And so it says, which of the following is equivalent? Well, 20 is not equivalent to 25 plus 25. What this is saying right here is, again, if we do order of operations, this is saying exponents first, right? Exponents comes before the multiplication. And then you'd have to do 2 times 25. Well, 2 times 25 is going to equal 50, just like 25 plus 25 equals 50. This would equal 100, and then this one right here would equal 5 times 5 is 25. Times another 5 is like, I think 125, and then times another 5. It's way bigger than 50. I think it actually equals 625. Let's keep going here. All right, 8 cubed times 8 cubed. We got to check the appropriate box. Let's see. This would be 8 to the 6th power, I think. Let's see, 8 cubed. That means 8 times 8. I almost wrote 8 times 3. I almost fell for the trap. And then there's a time sign right there. So all I'm going to do for that time sign is just write another time sign. It doesn't matter if you use the raised dot or the old school X. And then we have another 8 cubed here. 8 times 8 times 8. So I just wrote 6 eighths right here, if you see that. And so this is definitely true. 8 to the 6th power is definitely true. Let's see, they're saying 64 to the 3rd power. Well, 8 times 8 is 64. 8 times 8 again is 64. And 8 times 8 again is 64. So yeah, I would say that because I haven't used this multiplication yet, so I'll bring that down. And the same thing here. I'd say 64 to the 3rd power is equivalent to this. 2 to the 12th is also equivalent. 8 really is equal to 2 times 2 times 2. So that's one of those 8s. But remember, you have 6 of these 8s in all. So each 8 is worth, hopefully I'm not losing you, each 8 is worth 3 2s. And so if we have 6 8s, and they're each worth 3 2s, you really are looking at 2 to the 18th power here, because you do 3 2s. This is 3 2s. This is 3 2s, 6 2s, right? 3 more 2s, that's 9 2s. 3 more 2s, that's 12 2s. 3 more 2s, that's 15 2s. And finally 18 2s. So yeah, 2 to the 12th power would not be equivalent. It would have to be 2 to the 18th power. And then lastly, this one would be wrong, of course. 8 to the 3rd power, 8 times 8 times 8, that's what that means. But we didn't write times 2 right here. We wrote times 8 times 8 times 8. So yeah, this doesn't work either. And then this one will be my last one that I show you. X squared equals 441. 12 is a tempting answer, but 12 is, if you do 12 times 12, that'll only equal 144. So you want to get the same number times itself. And like I said, this will equal, whoa. So there it is, that'll equal 144. And so, if you go a little bit higher here, 20 times 20, that'll give you 400. And 400 is just a little bit too small. So this will actually be a little bit bigger than 20. It turns out to be, if you keep guessing, checking 21.